All right, everybody. So it's going to be a short video today. So really, I'm just here to explain how this graph works. Okay, so you guys should have your rock cycle web quest done right now. So you guys know sedimentary, igneous, and metamorphic rock, how those guys are formed. And then this week, what we're really doing is going into igneous rock, metamorphic rock, and sedimentary. We're going to do those individually. So this first part is really just a bell ringer. This one's these guys are just bell rings. Number two, I'll just go ahead and give you number two. It's kind of difficult. Identify a mineral that, if pure, contains only one kind of element. What do we call that? Or sorry, one kind of atom. I gave it away. It's an element. Okay, so gold is considered a mineral. Aluminum a mineral. Elements are a mineral. If pure, one kind of atom, right? That's an element. Okay. So there's your freebie for this bell ringer here, essentially. Two things that must occur to change sediment into sedimentary rock. So sediment has been made. Now, how do we make this sediment into sedimentary rock? So remember, sediment can be made from weathering and erosion. So now how does that sediment that has been broken down turn into sedimentary rock? That's what the question's asking. Okay. So then you guys read this about you're part of a volcanologist study group, and you're looking at these crystal sizes, and you're looking at the time in years, okay? So this doesn't look too bad. I'm going to have you guys graph this. It doesn't look too bad at first, and it's not until you look at this, right? What this is this is a logarithmic scale. What's logarithmic mean? It means it goes by the powers of 10. On the time scale. So over here, when we get crystal size in millimeters, these are straight 1 millimeter, 2 millimeters, and then we see these dashes in the middle. There's actually 5 of them, right? 1, 2, 3, 4, and 5. So that means these must go by 0.2, so 2/10. So this is 0.2, 0.4, 0.6, 0.8, and 1. 1.2, 1.4, 1.6, so on and so forth, okay? And then on this, these guys increase every time we go. So these increments right here, from here to here, if you took a ruler, they're the same distance. However, their numerical meaning increases by a power of 10 every time. Okay, so if we magnify 0.01, if we magnify that by 10, we get 0.1. If I take 0.1 times 10, I get 1. If I take 1 times 10, I get 10. If I get 10 times 10, I get 100. If I get 100 times 10, I get 1,000. Okay, so every increment, this all increases by a power of 10. Okay, and the reason why it's using this is because we're using a wide range of numbers, essentially. We're using a wide range of numbers. And so that's why we're using this logarithmic scale just for the years, okay? And so if I go back to here, I'll go ahead and help you guys with the first one. So it says, like I said, you guys can read all of this. It talks about the crystal size and how long that it's been cooling for. So crystal size is 0.2 millimeters, and the time they start with is 0.01 years, okay? So 0.01 years is right here on this first, right? And we need to identify this is the x-axis, and then this is the y-axis going upwards. So y to the sky, and x is the horizontal. So 0.01 and then 0.2 millimeters was our crystal size. And so that first guy would be right here. Okay. What's the next one? Next one is 1.2 and 0.1. So if we go over here to, here's crystal size is 1.2, and then it says 0.1. I'm going to follow it up to here. So 1.2 and 0.1 right here. Whoa, that was a little too big. It went off a little bit, but you guys understand what I'm saying. So it would be beneficial for you to print this out if possible, or try to maybe copy and paste this onto Paint and then upload that document to Wednesday. Chances are we're going to finish this up in class on Wednesday. I would like you guys to finish this for Wednesday, though, too, because we will get this finished on Wednesday, and I'll have these guys turn it in. Okay, but that's how this graph works, so go ahead and do that. And then when you go to answer all of these questions, what's the relationship between time it takes an igneous rock to cool and its crystal grain size? All of these are going to be pointing back to this graph that we've done. Okay, so think about time versus crystal size, how long it takes. and such. Okay, you're reading all of this and keep on pointing back. All right. So there's the bell, and if you guys have any questions, don't feel or please feel free to message me or anything like that.